Hello and thank you for watching this tutorial. This tutorial provides a high overview of the basic components that constitutes EQ development board. Now, the idea behind this board is to give the user a complete access to all the pins on the microcontroller. Now, this is the microcontroller. This is the brain of this board. Now, these pins are all routed through these buffer resistors onto these pins. Now, we will go through what each interface does, but for the meantime, what I'm going to do is to start discussing the components on this very board. The reason why we've given the user access to all these pins or the interfaces from this microcontroller is that most of the boards on the market today are designed for just one or two lab exercises. I'll start off by talking about the LDR. Now, this is the LDR. LDR is an acronym which stands for light dependent resistor, or you can call it a photoresistor. What it does is that it increases its resistance when the surrounding light is very bright, and decreases its resistance when the surrounding light becomes low. That is what it does. Now we have onboard regulator here, which is 5 volts regulator. Now, what it does, it converts any voltage at all which is passed through these DC sockets, and the voltage can be between 7 to 15 volts. Now, this regulator will regulate it to 5 volts for the onboard chips. Okay, although we've got an onboard voltage regulator and a DC socket here, but we can power this unit through the USB socket. Yeah. So if you are doing any project at all which consumes less than 100 milliamps, you don't need to use this. DC inputs. You can just power your unit straight from the USB. So just by hooking your board to your laptop, you can start doing your exercises. This board will come with a lot of exercises, lab exercises. Yeah, so you can straight go ahead and start practicing your programming. I was saying, now these potentiometers, one which has got the silk screen reading LCD brightness, and the other one reading ADC. Now, ADC is analog to digital converter. I will explain it when I come to explaining what a microcontroller is. Up to clockwise, see what will happen to the LCD. Yeah, okay. Now, when I start turning it anti-clockwise, see what happens to it. It becomes blank this way. Okay, now this one is for ADC exercises. Now, we've got a tiny chip here. Now, this chip is the chip which is responsible. I will explain it later, but it's the chip which is responsible for this SPI interface. Now, that means I can connect about 4 SPI modules to this my board, and select the computer. So what this chip does, it selects which module to display on the LCD. Okay, now on board also we have the FDTI chip. Now, this FDTI chip is the interface between the USB socket and the microcontroller here. It's like Max 232, but it does more than that. Maybe the components on this board we've talked about this two potentiometers. We've got a buzzer here. Then we have jumpers here. Now these jumpers, this very one here, there's a silk screen here, which is a bit difficult to see. But there's a silk screen there which reads LED jumpers. Now, the reason why I put these jumpers here, I might have to tell you that you cannot do any project which will require 10 pins in them. I've used 2 for voltage, that is a positive rail and negative rail, and the rest of them are signals or ports from the microcontroller. Okay, so if you count how many we've got, a general purpose one, which is the GPIOs. IO means input and output, but the GP, that's a general purpose IOs. You cannot do any project that you use all of them at a time. But all the same, I put these jumpers here that if you require in future, if you require a project, maybe you want to communicate between GPS and maybe at the same time sending information through GSM or maybe ZigBee or XB or Terran 4, okay, then what you have to do, if I start pulling the jumpers off, this light is going to go off. That means what you are basically doing, you are freeing those pins which are, or the control lines to this LEDs. So you pull all this off. See, it's gone off. That means I've taken the control line, so I've freed those control lines, so I can come and start using them on this socket. Okay, all right. So that's what this jumpers are for. Now I've got jumper here, which is also got a silk screen. It's also difficult to read, but what is written there is UART jumper. Now UART is one of the most important interfaces. I will come to it very soon when I start doing the microcontroller. If you want to communicate between GPS, you use UART. If you want to communicate between GSM through ZigBee, that is what these jumpers are for. Now if I put this jumper on pin 1 and 2, that means I have freed the communication links between the microcontroller and the PC, and I can go ahead and use the UART here, which is written here. I can go ahead and use this socket to drive anything that I want to drive, which requires UART. Okay, all right. Now I think basically I've talked about everything here. Now we've got 2 tact switches here. I will explain very soon what they mean, but yes, one is for master clear. Now master clear, I will come to what master clear is. So we've got a few things to under this very LCD here. Now bring one of the boards which I haven't mounted the LCD on. Now this is a board without the LCD. Now this board is such that it's sort of a future proof that if we run out of surface mount sockets for the LCD, I've provided a true hole version here. The components here, which is very difficult to see. Now these are FETs. FETs are field effect transistors. Now what they do, I've used them as switches. Now one of them is responsible for switching the buzzer on, and the other one is responsible for switching the backlight. There is a backlight on this LCD that one of them is responsible for the backlight. Okay. I have used the state-of-the-art technologies by using surface mount components, the tiny surface mount components. Now we're going to write a code using MPLAB IDE. Now IDE is an acronym which stands for Integrated Development Environment. Now this can be downloaded from Microchip website. This is free. There are third-party proprietaries which are not free. So if you come to my website, there's a link to Microchip website to download this IDE free. So let's start by double-clicking the IDE. Okay. Now I'm going to use a screen recorder. I'm going to use a screen recorder to do the coding. Okay, because I can't be holding camera at the same time typing. Okay. Now, after double clicking the MPLAB, which is the IDE, it will take you to this menu. What we're going to do is to select Project Wizard. Now, the Project Wizard can be found under Project. So let's click Project and select Project Wizard. Okay, next. Now, we are going to select the device we want to use for our project. In our case, it's PIC 16F887. Although it's showing there, but let's ignore it just to get used to selecting a device for a project. So I'm going to start typing 16, sorry, I have to start by PIC 16F887. Okay, there will be a slew of them here, but let's try and ignore them, and the very one that we've just typed in is going to be at the very top. So let's select it. Next. Okay. Okay, in this window you want to select the compiler you want to use. Now I'm going to use the CCSC compiler, which I previously installed. So I choose the CCSC, then next. Okay. Now in this window I'm going to create a new folder. So I'm going to name it LCD, but I think I've got few LCDs there, so let's give it LCD4. Okay, now we have to press browse. Okay, let's give the folder name LCD4, then save. All right, so next. Now if you have any other file you want to include in your project, you can include them here, but since this is your first project you probably don't have any, so click next. Okay, finish. Okay, so basically what we have done here, we've created, but if you look at this place very well, you realize that source file is empty, header file is empty. The source file is the code you write or the sense you put into the microcontroller. Okay, after clicking the file new, you get this white screen, so go ahead and type your code here. Okay, now I'm going to paste this sign there. For some reason I can't find it on my, I think I've changed my keyboard layout, so I've just pasted it there. Now I have to include the device, so open brackets 16F887, then close brackets. Okay, next line, what I'm going to do, I'm going to set the fuses. Now set fuses is just to configure the device that you have chosen. A lot of information on these fuses can be found in the data sheet. I'm going to do a tutorial to tell you how to use the data sheet, but let's go and set the fuses. I need this sign again, so now fuses, now it's going to be in capital letters, so enter, I will tell you what this means, RC underscore IO, comma, sorry, comma, then I'm going to use another fuse again. I'm going to use no failsafe. So FC main. Okay, comma. I'm going to use another one. No internal, external, external. So, comma again. Then I'm going to use no low voltage protect. Low voltage protect. Okay. Now, these are fuses. You can do this in the configuration bits, which can be found under configure, or you can do it in code. Now what we are doing it in code. This is just telling us, it's telling the CPU that we are using the internal oscillator of the microcontroller, and the last that's after the underscore is now, since we are using a internal oscillator, that means the input and outputs, the pins, can be used for any other thing. Okay, all right. So the second one too is no what I call it, no FC main. Now what that means is that we are disabling no, that means disabling fail safe. Okay, so this is disabling the fail safe, so sort of is fail safe enable. So what we are saying when we say no, that means we are disabling it. Now the third one, which is no ISO, well, that's the way I call it, but the meaning is that you are disabling the I, which is the internal external switchover. You are disabling that as well. Now everything is in the data sheet, so I'm not going to take my time and explain what that means, but you are disabling it. And the last one, which is it's no, not LP. So no LVP. That means I'm disabling the low voltage protect as well. That now this low voltage protect is when the voltage goes below the threshold. What should happen is that the processor to restart, or maybe will sort of stop working. But if I disable it, that means that is not going to happen. All right, so that is what these fuses are. Okay, now I can ignore them and just use this one, and I think by default it's going to disable this anyway. Okay, the next thing to do is to tell the CPU in the microcontroller what type of clock speed we are using. Now once again, the data sheet details all this information, so I'm not going to go into that, but we are going to use 8 megahertz. So how do we do that? We'll put this sign down, then we tell the processor, or the compiler, that we are going to use delay open bracket, close bracket, clock. I think I'm a bit fast, so it's clock, not the clock. Okay, clock is equal to 8M. That is 8 megahertz. Okay. All right. So the next thing to okay, now what we're going to do, like in any other C program, we have the main function. So this is where the main program will start from. So void main, main. Okay, open close brackets. All right, now start. So we use open brackets. Then I'm going to loop it. Now while I'm going to use a while loop, and what this while loop will do is that it will loop the program endless. So sorry, the one should go in there. Now I can write through here and it will still do the same job. Okay, so another open brackets. Okay, now this is where the code is going to be. I'm going to say output underscore B. So this is port B. I'm going to just send first 0 zeros in hexadecimal on port B. So open close brackets and 0x00. This is hexadecimal. Okay, now we need semicolon here. Okay, then after putting 0 0 on this port B, so anything at all which is connected to port B will go 0. Then I'm going to output high. I've got my LCD backlights connected to port A on pin 7. So I'm not going to turn all port A on. So I'm just going to select only port A, pin 7. So how do I do that? Output underscore high. So that means high means you should turn it on. Okay, so into brackets pin 7 underscore A7. So what this is telling us that, or is telling the CPU, is that it should turn on output high the pin 7 on port A. Okay, semicolon. Then what do? Now I have to delay it, turn it on and delay. So I'm going to delay it in milliseconds, so ms, milliseconds. Then open close brackets. Let me just put a semicolon and go back again in here. So I'm going to delay it for let's say 500 milliseconds, which is half a second. Okay, I can delay it for a second if I want, which is going to be 1000, which is a second. All right, so I've delayed it. What I'm going to do now, I'm going to output low underscore low. Let me put my semicolon and go back. I will explain why. Output pin underscore 7A. Now what I have, sorry, it should be capital letter. Okay, now what I have done, if you look at this place very well, I first put it on, I put this off, put this one on, the pin 7 on port A on, then I delayed it for half a second, then I have to put it off now, else you'll see it on all the time. So okay, I've put it off by using this command, output low, or this function, output low pin 7A. Okay, then what I'm going to do, I'm going to turn this on. I first turn it off, so I'm going to turn it on now. So what is going to happen? I'm going to say output underscore high, sorry, it's B. Now there's a trick here. I'll tell you what I'm doing. I'm going to put hexadecimal for 255. Now in hexadecimal it's going to be XFF. Now the reason why I've done that, I'll put comments here. Now if you put comments in your code, the compiler is going to ignore anything which is after that. What I can do, I can write it this way: B 1 2 3 4 5 6 7 8. I can write this in here and it will do the same job. All that this is doing, all that this is saying is that I'm turning on all the lines on port B. This is port B. So if I put this here, it looks a bit compact, but they do the same work. Okay, I'm going to leave it here anyway. I can comment it if I want somebody to understand what I'm writing. I can comment it. I can just write here 10 pin 7 on ports B on. That's what I can do. Then right here, so it should be 2// it's a comment. Now the compiler is going to ignore this, and I can come in right here, delay for half a second. Yeah, compiler is going to ignore half a sec, so it's going to ignore anything which is written after this comment. Okay, all right, so now let's continue. You see, I just said 4 lines, but I think it's taking 1 2 3 4 5. I think we are already 5, so I'm going to add last one and come out of that. I don't want to write too much here. Then delay the whole thing for, again, delay in milliseconds, ms into brackets 500. Okay, all right, that's it. So now I'm going to close the first bracket. So I close the first bracket. Oh, sorry, it should be closed after this. So I close the first bracket, then I close the second bracket again. That's it, the program is done. So what do I do from here? I'm going to save it. Okay, now I'm going to save it. Let's save it under the folder we created. Let's name the code also LCD4, and save it in the very folder that we created, else it's going to be everywhere. So I think projects, libraries, and LCD4. Where is it? LCD4. But since it's a C code, we have to add an extension C. Save. Okay, now let's add that very file that we've created to our source file. So right click it, add file. Yeah, we add this file, the file that we've just created. Open. Okay, it's added. Then we have to add our header file, which is the device that we chose for our project. Open. Okay, all right. Yeah, so I was having problems because I had the same project called LCD4. So what I had to do is to go and change it. Well, I've just changed the name to Guy, I think, which is the same thing, the same content. We've included a device here. We've set the fuses. We've delayed it. Well, we've used a clock speed of 8 megahertz. The main program, void main. Then we are going to loop it. It's telling us that we turn on, that is output high, the pin 7 on port A on, which I've commented is here anyway. So let's say for posterity sake, if maybe in 20 years time somebody should take this code, the person will understand because I've commented it. Okay, all right, now then you delay this 2 for 500 milliseconds, which is half a second. So I've written here delay for half a second. Okay, then you come to this place, you output low the pin 7. That means it was on, delayed. Now I'm going to turn it off and turn this one which was off on. Now, as I was saying, this is hexadecimal and it's the same thing in binary. That's what you get. So this one tells you that the port B all the lines on port B, because port B has got 8 lines, which is 8-bit port. Now I've turned all the bits on that very line, that very port on, which is 1111. That's exactly what this is doing. Okay, now let's compile it again. Yes, I'm getting some error. If you've noticed, I'm getting some error here. Well, I had to go back because I wasn't recording this side. Okay, now what this is doing, I think it's pointing to where the error is. It's telling me that line 58 expecting a close parenthesis. Okay, now close parenthesis, where is it? Okay, so line 58, this is line 58. Okay, how do I know that? I'm not recording that, but now this is line 50. Okay, that means I'm missing, I haven't closed it. I've opened a bracket here, parenthesis here, but I haven't closed it. So what I have to do is to go back and close it. Okay, so we'll close it now. Let's compile it again. If you do any changes at all, what you have to do is to go back and save it. So now let's save it. Save it. Let's compile it again. Hey, bingo, no errors. So that means we've been able to compile it. Okay, now what I have to do, that means I've got the hex file generated. How do I load it into the microcontroller? What we have to do is to go to configure, we go to programmer. In my case, I'm going to use PIC 2, so I'm using PIC 2. Let's go to PIC 2. We select PIC 2. Okay, now I'll show you now. Well, I'm recording the screen. I'll show you what I'm doing now. I've selected the programmer PIC 2. What we have to do here, the very file that we've just compiled is in hexadecimal file now, so we have to import it. So import. Okay, now you see it's generated here, guy, and it was generated. If you look at the time, we just generated it. That is, it tells even when it's 22:46. Okay, now let's import it. Okay, now this is telling us that we've imported this, and we can now download it into the microcontroller or onto my board. So now with the code that we've just compiled, we've been able to generate a hex file from the code that we've just written. So I'm going to power my board using this USB cable. Okay, the board is powered now. I'm going to use PIC 2 to program it. So I put a PIC 2 in the programming socket. Okay, now let's start by pressing the programming key on the MPLAB. Okay, so I'm going to press program. Okay, now it's programming. Alright, it's done. So this is telling us that the programming is done. Let's program. We can program many times. It's doing the programming. Yeah, okay, done. The PIC that is found here is the 887. Alright, now let's see whether it will do what we've instructed this thing to do in the code, the board to do in the code. So I remove the programming, and I think if the person reset, let's reset it and see. Yes, okay. Now you see the backlight of the LCD is changing, and at the same time it's switching this LED on and off. That's what we told the code to do. So the code, now this LED is on port B, okay. Then the backlight is being controlled by pin 7 of port A. So that is exactly what we told the code to do. So what this is doing is first 0 off, then pin 7 comes on, so sort of they work at the same time, and that is exactly what we instructed it to do in the code. Okay, thank you for watching. My next tutorial is going to be writing the code to turn motor on and off, and also writing the code to interface between the LCD and the microcontroller. Once again, thank you for watching. Microcontroller, or onto my